Hi, everybody. My name is Melissa Sussman. I'm the lead technical advocate at Sumo Logic, and welcome to Illuminate. I'm really excited to talk to you all about how Sumo loves open source. We're going to just do a general discussion around open source topics that Sumo has contributed to, some of our very amazing sweat equity, as well as do a little bit of a deep dive into OpenTelemetry and why that matters so much for us. So a little bit about me. I'm the lead technical advocate at Sumo Logic. I have about more than 11 years of domain expertise and experience as an engineer, product manager, product marketing manager, all for developer tools. I love gardening, reading, playing with Mary Lou, who's on the left, the dog, and working on side projects. Some notable side projects I've done in the past include things like running nodes on the Lightning Network, writing smart contracts, running game servers, mostly for fun, building dev kits back when I started out in the hardware world, sewing and woodworking. Sumo Logic loves open source. So Sumo has been actively investing in open source observability for the past several years. In addition to being a longtime CNCF Silver member, Sumo has also invested a lot of sweat equity into the open source projects listed here. So some of the really interesting recent announcements are, we have the OpenAnalytics beta, which came out in February of 2022, and it basically demonstrates the open nature of Sumo Logic's platform. April of 2022, we also have the Sumo Logic distro for OpenTelemetry collector. So most recently, we also have some stuff happening with Sensu Catalog. And just a couple of months ago, we were at Noble 9 SLOConf event, where we announced the contribution of SLOGen to the OpenSLO standards project. So the purpose of the OpenSLO standards project overall is to help SREs quantify the reliability of their applications through service level objectives, or SLOs. So Sumo Logic shared our contribution of SLOGen to the open source community, as well as our commitment overall to open source and OpenSLO as an emerging standard for expressing reliability management as code. We kind of go into a little more detail in the next slides. Here we're going to just talk about, first of all, how does open source data collection work? In this example, we use log, metric, and event and security data via Fluentbit, Fluentd, Prometheus, and Falco. All of these are open source data collectors maintained by the Cloud Native Computing Foundation. Again, we're a Silver CNCF member. We absolutely love all of that. Utilizing open source tools for collection and data enrichment is ideal, given that all these collectors receive a lot of community support and are typically, they have integrations for any type of data that you might want to collect. So here we can see on enrichment, everything gets funneled through a centralized Fluentd pipeline for metadata enrichment. Kubernetes is very rich with metadata, such as pods, labels, namespaces, etc. The metadata are descriptors of these Kubernetes entities and how they relate to one another. However, each log, metric, and event doesn't expose all of its metadata on its own. The purpose of this enrichment pipeline is to ensure that for every log, metric, and event, you know what container it's coming from, what pod that container is in, what the pod labels are, what node it's on, what namespace it's running in, etc. Things like what cluster it's running on. And ideally, this is accompanied by, tagging the container, pod, node, and cluster, but also identifying the service and the deployment for each entry. So again, with metrics essentially serving as that smoke detector, and then logs enabling us to kind of go down to the root cause, unifying these data sources around a common metadata language enables us to easily correlate these signals. We can easily pivot from the metrics of data about a cluster to the events data about a cluster, and then look at the data about said application. So onto the collection setup. So all of the setup can be done via Helm chart commands. It's as easy as, for example, Helm, install, and then insert the data collector. In this case, it's Sumo. The Helm chart can be used to configure and deploy open source projects like Fluentbit, Fluentd, and Prometheus, and Falco, of course. Then, the data comes over to a collection agent where the data is enriched with analytics and then stored. So let's talk a little bit about how each of these pieces in the data collection pipeline works. So we've got on the left, the logs. So for the log collection, in this example, we use a Fluentbit daemon set that runs on every node in the Kubernetes cluster. This will gather the logs and then ship them to the collector. And then we have metrics collection. So for the metrics, this example, includes Prometheus, which is the de facto choice for monitoring the Kubernetes cluster. The main strength of Prometheus is that it has auto discovery, and that works for pre-instrumented things in Kubernetes along with any custom instrumentation that you have implemented in your application. So because of that auto discovery, you're up to date with the state of your environment. It learns about new components for each of these things, should you decide to update data streams in your collector. And then, of course, we have events. So event collection. As for the events, this example assumes a Fluentd plugin for the agent that runs as a deployment. All events here then go to the API server. So the plugin essentially watches the API server, and then new events are detected as those are shipped over to the collector. This example also utilizes Falco, which is an open source tool that detects anomalous activity and security events. So once deployed, Falco uses that kernel module, user space libraries, and Kubernetes audit events to watch for any security event matching one of the conditions defined in the Falco rule file. So notifications are issued for matching events and collected with the Fluentbit open source project, just like with the logs. So now that you understand a little bit about how open source collection works with existing CNCF projects, we're going to dive into key concepts for reliability management. In this case, SLOs, SLIs, and SLAs. So according to the book on database reliability management, services that we design and build must have a set of requirements about their runtime characteristics. This is often referred to as service level agreements, or SLAs. SLAs include remedies, impacts, and much more. So we're going to focus on service level objectives. SLOs are commitments by the architects and operators that guide the design and operations of the system to meet those commitments. This is from, Lane Campbell and Charity Majors. So why does this actually matter? Okay, basically, let's say that you're a game company or, a streaming service, and you need to maintain a certain level of service for customers. You can only tolerate a certain level of downtime before you begin to basically lose users. So you would set a service level objective as an organization for that particular application. The site reliability engineer may also come up with service level agreements in order to remedy those downtime issues. And this basically helps them sleep at night. Hopefully all of you SREs out there can empathize with the meme, when our brains won't turn off at night, even past bedtime. SLOs help teams define the reliability of their systems and services to make smart decisions about how to build and run applications. So service level indicators, or SLIs, are a component of SLOs and measure how a service, typically measured in things like, percentages, is performing. OpenSLO aims to standardize this via their application and their specification. So follow that link to learn a little bit more about OpenSLO. Slogen is an open source SLO as code CLI tool, basically based in the OpenSLO specification. So this one's actually the application. Slogen interprets SLOs and then alerts strategies, defined by the OpenSLO specification, and automatically creates those SLO dashboards and monitors. So to learn more, you can follow the second link, and check out both GitHub links if you wanted to learn a little more. So now on to why unified collection matters. So to me, this is the heart of the presentation. So here we have an example of what could happen if teams are collecting data without full observability into what others on the team can essentially see. So one here obviously thinks that it's a spear, another thinks that it's a tree trunk, another thinks it's a rope, etc. So as long as they cannot observe what others can, there is poor data fidelity. This is an analog for what happens in the IT ops world. So ideally, infrastructure engineers should not need to enact application changes due to sending data to various, disparate backends. But they often have to use disparate backends. So once a disparate system becomes much larger, particularly in, federated models where you have some folks in one part of the organization that use one particular backend or one particular system, and others in another part of the organization that use something else, largely software as a service, standardization around telemetry becomes very important. What if you want distributed tracing data to be analyzed somewhere other than that one tracing backend? What if your team wants to route logging data to a security analyst in a format other than that flat CLI in the logging backend? People want to use histograms, charts, graphs. They want machine intelligence to statistically analyze and parse through all of this data. This is only possible assuming a unified telemetry standard that is vendor agnostic. People often ask, why would you as a company care about things being vendor agnostic? Well, transparency around data collection is vital. We know that having a vendor-neutral format is important for data collection processes. So with that in mind, we can cover the anatomy of telemetry so we can better understand why this matters. Here we have a telemetry pipeline as an example. A telemetry pipeline basically routes the data that comes in the form of logs, metrics, traces, etc., from where it is generated to wherever it needs to go, which is often on disparate backends. This also intersects with the way in which the routing data is expressed via monitoring. So telemetry pipelines not only use and filter this data, but produce enriched metadata that's available to various backends regarding disparate information, things like the Kubernetes container information we talked about earlier, the region information, the geo IP information, and other logging and trace data. So OpenTelemetry, which is OTel, as most cool kids call it these days, is an open standard for collection that is vendor agnostic. It is essentially a format for trace data that attempts to unify the receivers. In this example, you can see that the receiver is at the top, and that's generally where we start. OTel comes from basically unifying projects like OpenSensus, which originally came from Google, and OpenTracing from CNCF. OTel captures the traces, the metrics, the logs, and other application telemetry data on any backend of your choice. So as we go through this example on the telemetry pipeline and its corresponding components, we can see an extremely basic setup, which has a receiver, a buffer, an exporter, and a processor. Typically, pipelines, chain buffers and processors, so you can have a buffer, processor, pretty much indefinitely, which takes data and basically analyzes or transforms it. We start out with this receiver, which essentially can be in the form of those logs, metrics, traces, and the buffer can exist, it's in gray, it can exist within the processor, or it can also exist within the exporter. That just basically stores the data. A lot of the time, people automate compliance checks, for example, on deployments. So that essentially goes through something like a processor, and that can give you that enriched data. The exporter is essentially what you get at the end. So that is the end of the telemetry pipeline where the data is exported to its corresponding backend. So you can essentially use data that comes from exported logs and then goes through various compliance and security checks, like things like GDPR and HIPAA, via those chains of buffers and processors before finally exporting a result. A pipeline can get extremely complex, but typically keeps the pattern, again, of receiver, buffer, processor, and exporter for just about every type of backend. Here's the big question. Why in the world would we need to have disparate backends for data collection? Well, many app developers, SREs, DevOps engineers, and security analysts have to work around compliance and data protection, especially when dealing with information that could be personally identifiable. So how does this relate to data collection on OTel? The answer is it becomes impossible to approximate system-wide health across disparate backends without a way to unify collection methods. Additionally, you don't want to store data in the same place that you're running a video game, for instance. You might actually have user IP addresses, API keys, and passwords that would have different storage in separate places. These are essentially, you have to think about GDPR and COPPA and FedRAMP requirements. And the team, in this case, a DevOps team, needs to think about essentially how to meet all of these requirements. And that can lead to a lot of disparate tracing and routing to said backends. And gaming teams will often be working with personally identifiable information of children, and applications need to log that data related to these kids in a way that is compliant with COPPA or the Children's Online Privacy Protection Act. In that particular use case, there are limits to where the telemetry data can be stored, who has access to it, and how long the data can be stored before it has to be deleted. The same happens in social media platforms, streaming services, and a wide variety of other applications. And here we have Grace Murray Hopper talking about how the wonderful thing about standards is that there are so many of them to choose from, ironically, of course. So here we see an XKCD comic sort of lightheartedly poking fun at the increasing number of standards in an attempt to unify what is available, only to end in additional competing standards. So on the left, we see the Open Census and Open Tracing projects, each individually originated at Google, but since then the projects essentially have a shared common goal of data unification and merged in May of 2019 under CNCF governance. So that is now OpenTelemetry, which is backed by major vendors and has an incubating status as of now. Foundation work is helping to prevent the problem identified by Grace Hopper and, the XKCD comic. So we don't want multiple competing standards, and I know that these older projects are already being brought into OTel. This slide aims to contextualize the open source concepts explored in prior slides in a diagram. So here we basically see a hodgepodge of vendor-approved collection, instrumentation, and backends. This is what data collection looks like without using the OTel standard. Generally speaking, we can break the observability architecture into these three layers. So the first one is actually generating that data. So the logs, spans, and metrics input. This happens through the instrumentation layer, which is tightly coupled to the program code. It can be handled manually, automatically, or semi-automatically. With the solutions available just a couple of years ago, you would need to have a separate library for handling each of these signals. So in the next one, you see a collector or an agent/collector. As you want to keep a small footprint on the instrumentation library, the collector comes in handy with providing all sorts of processing capabilities, such as what we were talking about earlier, buffering and handling connections to said backends. It also provides enrichment capability, which attaches metadata about the origin of said data. That helps you navigate the signals, which now include information about the source, such as, instance ID and Kubernetes pods and the stuff we talked about in the beginning, custom tags, blah, blah, blah. So the last layer here is the backend, and that stores the data, which provides essentially query and visualization capabilities. This is what you're using when monitoring what's going on in real time. So as you can see, there are a lot of moving parts in each layer. Additionally, there are several instrumentation libraries available through different vendors. So when you want to switch from one vendor to another, you have a significant problem here. You might have already invested some time in writing integrations using disparate APIs. So with unique configurations and such. You would need to have all of this redone when switching between libraries. So I know that a unified collection methodology is a unicorn currently, and we may not fully be there today, right? But we're well on our way to the diagram on the right with OTel. So this is the difference between, open telemetry and observability. We think about the 1.0 versus 2.0. One of the, brilliant principal engineers we had, Shemek, came up with this concept of 1.0 and 2.0 for observability. I really appreciate the before and after state that's outlined here, basically. He said that overall, we haven't fully moved from 1.0 to 2.0 yet, but we're much closer to getting there as a community now due to the OpenTelemetry standard. If you recall, all of the stuff on the left basically requires a separate library, right? An agent for each of the signals in observability 1.0. This is not the case for OpenTelemetry, where pretty much anything except the backend is streamlined and provided by the initiative. So in that case, there are common libraries, collectors, and such. The vendors can provide their own distributions, but they all share the same common core code. And this is why Sumo cares about it. Even if, we care about selling our stuff, we still care about that particular piece being vendor agnostic. So, because we recognize that a lot of customers have a variety of federated models, and we would plug in differently depending on customers' needs. So we now have a single library that could handle instrumentation, both manual and automatic. We also have a single agent collector, which allows you to plug in, many data sources and correlate each signal. It includes a rich set of processors and exporters for open standards and multiple vendors through OpenTelemetry, which encourages vendors to adopt an OTLP. This standardization allows for vendor-neutral trace formats that can then translate to common span event formats. And that can easily be utilized in big data tools to produce in-depth analytics from data collection via the pipelines discussed earlier. In that structure, the OpenTelemetry collector acts as both, a receiver and an exporter somewhat. The OTel, as a standard, not only allows for format standardization, but allows you to use, in the case of an OTLP, the same agent to collect logs, metrics, and traces. So basically, in summary, OTel allows you to focus more on analytics by helping you with unifying the collection process. So here's, an example of how you might want to contribute to OTel. Here's some suggested steps. If you don't know where to start, it's good to go through issues labeled as help wanted or good first issue. On the, right side, we see this screenshot of several of those OpenTelemetry Java projects. Frequently, it's enough to just leave a note that you'd like to start working on a given issue. If the scope of the work is huge, it's good to sort of split it across PRs. So for example, the first one can include interface changes, the second can include, implementation, and then the third enables an actual feature. So specific instructions are available in each repo, and you would need to read it as well as overall guidelines. Also, you will need a click-through license agreement before you first commit and before that or contributor license agreement before it gets accepted. It's a simple process basically described in the documentation, contributing.md. Thanks for your time. I hope that you get a chance to actually contribute to the OpenTelemetry project, and I hope that you like this presentation.